Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on Y parameters of two-port networks. Let's start. Study some important terms. First term, one-port network. Statement, a network in which current enters through one terminal and leaves through another terminal. Refer the diagram of one-port network. Current IA entering into network and current IB leaving from network. Second term, two-port network. Statement, a pair of two-terminal network in which current enters through one terminal and leaves through another terminal of each port. See the diagram. Currents IA and IC entering into port 1 and 2 with currents IB and ID leaving from port 1 and 2 respectively. Up till now we have studied important terms in two-port networks. Let's study representation of Y parameters as if voltages V1 and V2 are independent variables, then currents I1 and I2 are dependent variables. Now Y parameters in equation form represented as current I1 is equal to admittance Y11 into voltage V1 plus admittance Y12 into voltage V2, which is given by equation 1, and current I2 is equal to admittance Y21 into voltage V1 plus admittance Y22 into voltage V2, which is given by equation 2. The short circuit impedances represented in two-port networks with voltages V1 and V2 as, let's refer the diagram. A two-port network is given with voltages V1 and V2 are inputs at port 1 and 2, and we are measuring currents I1 and I2 at port 1 and 2 respectively. Please remember the currents directions at the time of analysis of given networks or circuits. Let's study case 1 of short circuit admittance. Now substitute voltage V2 is equal to 0 into equation 1 of Y parameters. We get short circuit admittance parameter Y11 is equal to I1 upon V1, where voltage V2 at port 2 is 0. Now refer the two-port network diagram. Voltage V2 is equal to 0 means port 2 is short circuited and we are obtaining Y11 at port 1 only using current I1 and voltage V1. Now study case 2 of short circuit admittance. Let's substitute voltage V2 is equal to 0 into equation 2 of Y parameters. We get short circuit admittance parameter Y21 is equal to I2 upon V1, where voltage V2 at port 2 is 0. Now refer the two-port network diagram. Voltage V2 is equal to 0 and we are obtaining Y21 at port 1 and 2 using current I2 at port 1 and voltage V1 at port 2. Let's study case 3 of short circuit admittance. Now substitute voltage V1 is equal to 0 into equation 1 of Y parameters. We get short circuit admittance parameter Y12 is equal to I1 upon V2, where voltage V1 at port 1 is 0. Refer the two-port network diagram. Voltage V1 is equal to 0 means port 1 is short circuited and we are obtaining Y12 at port 1 and port 2 using current I1 of port 1 and voltage V2 at port 2. Now study case 4 of short circuit admittance. Let's substitute voltage V1 is equal to 0 into equation 2 of Y parameters. We get short circuit admittance parameter Y22 is equal to current I2 upon voltage V2, where voltage V1 at port 1 is 0. Refer the two-port network diagram. Voltage V1 is equal to 0 and we are obtaining Y22 at port 2 only using current I2 and voltage V2. The short circuit admittance parameters of two-port networks in matrix notation are represented as current I is equal to admittance into voltage, where currents I is equal to I1 and I2. Admittance is Y11, Y12, Y21 and Y22, and voltage is V1 and V2 respectively. We just studied important cases of short circuit admittances. Let's solve example on the same. Example statement: find the Y parameters for the network shown. Let's see given data. Resistance R1 is equal to 2 kilo ohm, R2 is equal to 4 kilo ohm, R3 is equal to 12 kilo ohm and R4 is equal to 10 kilo ohm, where voltages V1 and V2 are independent variables and currents I1 and I2 are dependent variables with ports labeled as 1 and 2. Solution: case 1. We are obtaining short circuit admittance parameter Y11 is equal to I1 upon V1 with voltage V2 is equal to 0 at port 2, means obtain current I1 in terms of voltage V1 and total resistance. Now calculate total resistance as total resistance is equal to R3 parallel to R4 plus R2 which is parallel to R1, where resistance RA is equal to R2 plus R3 parallel to R4. Now total resistance is equal to R1 parallel with resistance RA, which is given by equation 1. Let's calculate resistance RA as resistance RA is equal to R2 plus resistance R3 parallel with resistance R4. Now substitute resistance R2 is equal to 4 kilo ohm, R3 is equal to 12 kilo ohm and resistance R4 is equal to 10 kilo ohm. After calculation, we get resistance RA is equal to 9.45 kilo ohm. Let's substitute value of resistance RA into equation 1. After calculation, we get value of total resistance is equal to 1.65 kilo ohm. Then current I1 and Y11 are calculated as current I1 is equal to voltage V1 divided by total resistance, which is equal to V1 upon 1.65 kilo ohm, which is given by equation 2. We know short circuit admittance parameter Y11 is equal to I1 upon V1, which is given by equation 3. Let's substitute equation 2 into equation 3. We get Y11 is equal to V1 upon 1.65 kilo ohm divided by V1. After simplification, we get value of Y11 is equal to 0.6 millisiemens. Solution: case 2. Here we are obtaining short circuit admittance parameter Y21 is equal to I2 upon V1 with voltage V2 is equal to 0 at port 2, means calculate current IP and IR2 through resistances R1 and R2, then find current I2 in terms of current I1. Now calculate current IP and IR2 as current IP is equal to V1 upon R1, which is given by equation 4. Substitute voltage V1 is equal to I1 into 1.65 kilo ohm and resistance R1 is equal to 2 kilo ohm into equation 4. Then we get current IP is equal to 1.65 into I1 divided by 2, given by equation 5. Let's use KCL at node M. We get current IR2 is equal to current I1 minus current IP, which is given by equation 6. Substitute equation 5 into equation 6. We get current IR2 is equal to 0.35 I1 divided by 2, which is given by equation 7. Now using current division rule, find current I2 as, please note that current I2 is in opposite direction of current I1. Therefore current I2 is equal to minus resistance R3 divided by resistance R3 plus R4 into current IR2. Substitute values of resistance R3 is equal to 12 kilo ohm, R4 is equal to 10 kilo ohm and current IR2 is equal to 0.35 into current I1 divided by 2. After calculation, we get value of current I2 is equal to minus 1.05 into current I1 divided by 11, which is given by equation 8. Using equation 8, calculate current I2 as current I2 is equal to minus 1.05 upon 11 into current I1. Now substitute value of current I1 is equal to V1 upon 1.65 kilo ohm. After calculation, we get current I2 is equal to minus 0.0578 into 10 raised to minus 3 into voltage V1. Using value of current I2, calculate short circuit admittance Y21 as Y21 is equal to minus 0.0578 into 10 raised to minus 3 into voltage V1 upon voltage V1. We get Y21 is equal to minus 0.0578 millisiemens. Solution case 3. Short circuit the port 1 where voltage V1 is equal to 0 with short circuit resistance R1. Then calculate short circuit admittance parameter Y12 is equal to I1 upon V2 where voltage V1 is equal to 0 at port 1. Refer the previously studied diagram. Using nodal analysis, calculate voltage VA as apply KCL at given node. Voltage VA upon R2 plus voltage VA upon R3 plus voltage VA minus V2 upon R4 is equal to 0, which is given by equation 12. Now substitute resistance R2 is equal to 4 kilo ohm, resistance R3 is equal to 12 kilo ohm and resistance R4 is equal to 10 kilo ohm. After calculation, we get voltage VA is equal to 0.23 into voltage V2, which is given by equation 13. Using value of voltage VA, we are now finding current I1 and Y12 as current I1 is equal to minus voltage VA upon 4 kilo ohm. After substituting value of VA, we get current I1 is equal to minus 0.23 into voltage V2 divided by 4 kilo ohm, which is given by equation 14. We know short circuit admittance parameter Y12 is equal to I1 upon V2, which is given by equation 15. Using equation 14, then equation 15 becomes Y12 is equal to minus 0.23 into voltage V2 upon 4 kilo ohm divided by voltage V2. Simplify the terms. We get Y12 is equal to minus 0.0575 millisiemens. Solution case 4. Short circuit the port 1 which gives voltage V1 is equal to 0. Then calculate short circuit admittance parameter Y22 is equal to current I2 upon voltage V2. Refer the previously studied diagram. Calculate equivalent resistance as equivalent resistance is equal to R2 parallel with R3 plus R4. Substitute resistance R2 is equal to 4 kilo ohm, R3 is equal to 12 kilo ohm and resistance R4 is equal to 10 kilo ohm. After calculation, we get equivalent resistance is equal to 13 kilo ohm. Using value of equivalent resistance, calculate current I2 and Y22 as current I2 is equal to voltage V2 divided by equivalent resistance, which is equal to voltage V2 upon 13 kilo ohm, which is given by equation 16. Just to review, in this video we have studied short circuit admittance parameters with its equations and calculations of parameters using two-port network. Also, we have studied example on the same. Thanks for watching my YouTube channel. Thank you.